Hello and welcome to TidyX. It's a screencast where we review Tidy Tuesday code submissions and review them and explain them. My name's Ellis Hughes. I'm a statistical programmer at Fred Hutch Cancer Research Center, and you can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward, and I do data analysis in sport, and you can find me at OSP Patrick on Twitter. If you're interested in any of our previous TidyX screencasts, or you're interested in maybe trying to get a different bit of code explained or something like that, you can always hit us up at tidy.explained@gmail.com, and that's explained fully spelled out.
All right, so the data this week comes from Tour de France. So somebody created a package to help people access this. And so Thomas took the code here, or took the data here, and generated a few CSVs for us to download this week. It looked like people had a lot of fun kind of going through the data and exploring it. But one that we thought was really good this week was from Owen Churches, where he actually generated this animation showing how the various teams, the winningest teams over the course of the Tour de France have fared. So this is the animation that he's showing, and we're really excited. He also shared a gist of it, which exists here. A gist is on GitHub. It's kind of like you just share a single file rather than creating an entire repository of all the code here. So we talked with him. He said it was okay for us to go through it. So we took it and plopped it down here in our session. So I'm going to quickly refresh that. So it's all fresh for us to do this all. So at the very top, he has his library. So all he's using, Tidyverse. So this is great that he's using just the library Tidyverse to download all the data. But he's got this new library called gganimate. And gganimate was built by the same guy that we talked about last week, where he built Patchwork. So he's been really busy creating a lot of these great extensions for ggplot too. And so this is gganimate. And what it does, it adds tools for us to be able to animate our ggplots without much additional effort. And so we'll go over quickly how that works once we get down to the plots. In this step here, he loads the data in from the URL. It looks like he's only bringing in the one CSV. There were three, but he was only interested in this one here. So that's how he's able to do that with that URL there. In this first step here, it looks like he's not really exploring the data. I think he already had an idea of in his head of what he wanted to be plotting. And so here he took the TDF winners data frame, or Tibble, and used this function called count. So count goes through and counts the number of times that this record exists. And TDF winners is a data frame where it records each year and then which team, there's a lot more information here, but it only records which year and which team won. And that is winner team. So what he's able to do here is generate a smaller data frame of what the winner's team is and the number of times that they won it. Next, he uses this function top_n, which we haven't covered yet. But what it does is it looks at the top number of times that the vector, or the number, or the largest n that exists, and extracts those top n, in this case is 10, rows from the data frame. So if you do that quickly, you only have the top 10 teams. But if you can see, there's actually 11. That's because there's a tie here with 6 wins. So it kept all of those for us, which is a good thing to keep all the tires. And then he uses this function pull. So it's similar to select in that you're able to specify a column that you want to be using. But in pull, you can only specify one column, and it'll actually extract it as a vector of what the column was originally. So if we run that, rather than having a data frame, we now have a character vector of the top 11, actually in this case, teams that existed in Tour de France. So now he starts doing some processing in order to generate the data set that he's going to be using for plotting. So he goes through, he uses the same original TDF winners data frame, but here he adds an additional argument into count where he has start date too. So start date in this data set is equivalent to the year that the Tour de France was run. So you can use that as a proxy for the year date. And so here he goes through and generates a vector of the start date and the winner team. Next, he uses this complete function, which is actually a function that Patrick and I hadn't seen before. And so what it does is it allows you to specify more or less the combinations of the start date and the winner teams, and it fills all the cases that don't exist with a 0 right here. So that's what he defined it with here. So what it does is we're able to then generate a complete data frame where it has the start date, every single team that has won the Tour de France at least once, and an N value, which is 1 if they won, and then here he's specifying as N equals 0 if they didn't win, which will come into play in a second here. So next he uses this arrange, and so what this function is going to do is going to resort your data frame based on the column or columns that you put into it. And so here it's start date. And so what it's going to do is going to rearrange all your data frame so that everything is ordered by start date. He next uses this group by function to specify, okay, for the next couple of steps, what I'm going to be doing is only calculate it across all the cases where winner team is the same. So that he can look at this function here, where it's calculating cumulative wins. So there's this function cum sum. Patrick, do you want to maybe take a second and explain what cum sum is?
Yeah, it's basically just a function that gives you a rolling sum over time. So for example, if in row 1 the value was 1, and then row 2 the value was 3, it would keep adding up over time, basically compounding on itself. So something like this can be useful for projects of this sort where you're trying to evaluate a sort of a cumulative wins over time, or cumulative, you could use it in other types of like physiology type of data, like maybe cumulative distance over time and things like that.
Mm-hmm. So I just did a quick little demo here at the very bottom of the screen showing cum sum called on a vector of 1, 1, 0, 0, 2. And as you can see, the first value matches, but then the second value adds these two values together, and that's why it's 2. There's 2 zeros, so it doesn't add any new additional values, and then the final value in the vector adds the 2 to it. So just make that a little bit clearer. All right, so now he calls ungroup, and so this is a critical part of, if you're using group by, you want to call ungroup if you don't want to be calculating things across that group anymore. And that tells it to remove that when it's looking to calculate over time. Now it's going to be using this filter. So this is going to remove all the cases where winner team is not in TDF winningest, which is what we calculated up here, which is the top 11 teams of winners across Tour de France history. So that's what he calls there. And then there's this little mutate over here. And what it's doing, it may on first blush look like it's not doing a whole bunch, but what it's doing is it's replacing this hyphen with this hyphen, which it took us a second to kind of understand what was going on here. But it's because this hyphen is not a standard, because as you type into RStudio, these hyphens match. So this is a different encoding. And so if you try to be, if you're trying to call out the winner team, if you typed it into your RStudio session, it won't recognize that. So you have to replace it with the standard UTF-8 hyphen. So all right, we run all that, and so now we end up with a data frame that has the start date, the winner team, the number of wins that they've had, or whether they won or not that year, and then the cumulative number of wins they've had across the history of the Tour de France. And so next he creates an unanimated plot to test out his idea, because he has a theory in his head about what he wants to be plotting, and here's where he actually first tests it out. So he puts TDF cum into the ggplot. He uses geom_line, which will connect the points between x and y and make a line plot. Surprise, surprise. Here he's saying that the size of that line should be size of 2. The x-axis is the start date, and y is the cumulative number of wins, and he's coloring it by the team. So this will make 11 different lines because he specified color equals winner team. It'll color it by the 11 different teams here. Now he is coloring the lines. I think it's coloring the lines by the cumulative total number of wins they've had. And then he sets a theme to be minimal, so it's a very, very basic ggplot object that he generates. So let's generate that. All right. So here you go. I actually don't think that the scale y continuous. Oh, no, excuse me. Scale y continuous. For some reason, I was thinking coloring. So this is going to put marks at each of the winners brackets here. So yeah, it's a great plot to show how over time different teams compared to one another. Patrick, I think you had a comment about this down here.
Yeah, so he used the complete function, which gave every permutation of team and date setting 0 for any time the team didn't have a win. And so what you ended up getting is these kind of straight lines where teams essentially don't exist. For example, Team Sky and U.S. Postal Service, the two teams in pink there at the bottom, they weren't teams there, you could see, until around 1999. So effectively they are zeroed out. I think same thing with like Peugeot Wolber, the purple team, who had a lot of wins initially on, and then around whatever that is, 1920 or 30, something like that, they essentially flatlined because I believe they ceased to be a team at that point. So now they're effectively their cumulative wins can't go up any further. It's essentially whatever they had, their 7 wins, they have now for forever. So I do think
never take it away.
Yeah, exactly. If you ran the code without complete, I think you would essentially see, like, for example, Peugeot Wolber up until that 1920 period, and then they would just stop, and they would no longer be in the plot. And then same thing, Team Sky and U.S. Postal Service, as time goes on, there'd be nothing for them, and all of a sudden you would see them, what clearly appears like come into play and immediately have dominance. Of course, we know why that is, but well publicized. But yeah, so I think that's just a function of using the complete function there. The plot ends up looking like that. It's not a good or bad thing. It just is. So it's just a different idea, and if you wanted to plot it differently.
Yeah, it's just having context is important. I think it's also really interesting because this really shows that there are some teams that just have dominance over a series of years here, and they just rack up a number of wins. And it looks like France, unsurprisingly, just gets wins and streaks. And I thought that was really interesting how it broke up like that. All right, so next he moves on to the actual animation bit. So this step here is creating a named vector. So he's creating a vector of, this is the name of this entry and the value is blue. And so this is going to be used, so he says that it's the colors to match the jersey colors of the team, which is, I think that's pretty cool. So he does that, and then he throws it into the ggplot, but this time he's adding some animation elements here, so we'll go over that. We'd also like to point out that as you're working on new projects, it's a very good idea to go to look at the vignettes of packages, because they usually have a lot of really great information about how to use the package and are really able to take you from 0 to creating your first plots or animations or whatever you're doing, and really get you off your feet or get you moving and trying out the new stuff. All right. So what he's doing here is he adds TDFQM again to the ggplot2, and he defines his aesthetics up in the top. The same aesthetics actually that we were using in the static plot here. And he has a geom line. So this is exactly the same sort of plot that we generated here on the right. Next, he adds these bits here, which are specific for his animation. So he has adding a geom point with the same aesthetics that he's using with a geom line, so they'll match along with it. But in this case, he's now adding, so they'll be white dots, and they'll move along with the front of the point here. And now he adds a geom text. And what that is it's going to actually put in the team name to the right of that geom point there. So now we can see as the points move which team that is. And so that's kind of a fun way to do it. This scale color manual is exactly what we're using, or no, that's new, excuse me, where he's adding colors to be the team color jerseys. So that's what the values equals calls 1 is doing here. Next, uses scale color continuous, and that's what sets the y-axis breaks. And then this is the part here. That is the only line. Transition reveal is the only part that's adding in the animation. So it's got a really powerful API there to be able to add all this animation in this simple step here. And so what it's going to do is over each value of start date, it's going to progress forward 1, then replot, then progress forward another start date, and show everything behind it. That's what the reveal is. Show all the past start dates as well. So it's going to over time update and plot the wins over time. Then chord Cartesian clip off. We weren't sure what that was, so let's take a quick look at what this guy does. So clip. So it's gonna. So he has a clip off. So that's probably, it's going to keep it from clipping off the ends of the plot panel. So I'm assuming that's so that it can show the additional text and whatnot as it goes. Here he adds the labels. So he's labeling the title X and Y. He's setting the theme back to minimal. And here he's setting the theme, the plot margin. So he's setting the margins for us. So let's run that. And so now it's saved in this anim object. And then he uses anim save to save it as a GIF or GIF. So let's just run that because we're not going to save it. But if you run it here, it'll show up in our viewer. So here it's going through, and the gganimate in the back end is running a bunch of code for us, and it's generating a bunch of images that are then generated into this GIF. And so you can look at this over time. And so, it's a cool way to, progress and see how it all progresses over time. Animations are a really powerful tool. You should always think about the way you're animating it and ask yourself, does it add value to the plot that I'm going to be using here? Because it's really easy to get distracted and create really cool plots with gganimate, but not have it add any value to it. All right, and so that is what Owen Churches did for Tidy Tuesday this past week. Thank you, Owen, for allowing us to explain your code. And allow us to give a little demo of gganimate. All right, so now we're going to go and apply the same technique to a new data set. And so, Patrick, do you want to take us through this?
Yeah, so this week's data set comes from the NWSLR package, which is maintained by Ariel Dror and Sophia Tanner. And so this is a cool package. They did a cool job where they basically created a way to scrape all of the NWSLR data. There's several different data sets you can get there at a team level, at a player level, etc. So we load that package in from their GitHub, and then right there is the information on how to install it. So we'll load that package along with Tidyverse and gganimate. I usually set my theme right at the start because theme BW is what I like. We'll use the 2019 data, so the most recent data here. So we'll just select that. We'll use their the game data from their package there, and I put it into a Cabal table there just because once we knit this into a Markdown file, it'll make a nice table for us on the in the report. All right, cool. So We'll do a bit of pre-processing here. So the first thing I did was, if you look at the data frame there down in the console, you'll see that the teams are split between home and away. So basically what I need to do is get a data set that is just team and points scored. So basically what I do is I select out every team as a home team, right? And I rename those columns. So anytime they were a home team and how many points they scored, anytime they were an away team and how many points they scored. And then I bind those rows together to get this one single data frame that I call season total points. So now we have every team, every game, all the dates for all those games, and the points that team scored. Okay. We then calculate the cumulative points as the season goes along. So again, we're going to use that cum sum function there. We group by team. So for every team, it's going to show the accumulated points as the season goes along. And there we look at our favorite team, obviously, because we're in Seattle, the Seattle Reign. So we can see.
Rain.
Yeah, there you go. We can see how many points. That's the first 10 rows of a 25-row or 25-game season. Okay, so we'll get into the visualizations. The first thing I did, similar to what Owen did and what Ellis talked about, was I just do a static plot. So I just plot a bar plot here. Really simple, basic kind of bar plot. Nothing super fancy. All of these functions are things that we've done in prior screencasts. So go ahead and we'll run that. The only new one I did actually add in was the annotate function, which is to get league winner there. So annotate right there in the middle. I say that I want to annotate some form of text, which is I put it in quote. I give it an X and a Y, so that's where I'd like it to be, is X coordinate 30, Y coordinate 9. I want the label, the text, to say league winner, and I want the size to be 10 and the color to be red. That's what we see in the plot when we look at it, is we see that North Carolina was the league winner by far and away. They're 62 points. I mean, they're 20 points better than the next best team, which was Chicago, who they played in the championship. So there's no parity in the NWSL. Apparently, the best team wins. There's no randomness. There's no randomness in the league. The best team wins. I mean, they won by a landslide. So we'll go ahead and we'll turn this into two different types of animation plots. So the first one we'll use is a racing bar plot. Most of this information is the same. The only thing a couple things that I did change. Mutate there, I added a column called game number. And the reason I did this is because you'll notice that the information in our data set is date, team, and points scored, and then cumulative points for the season. But not every team plays on the same date. And so if we try to then animate this, it's going to show teams dropping in and out on dates when they didn't have a game. So instead, I just create this game number column where I sequence along the teams within the data set. So that gives us their 1 to 25 for each game. And then we get into the GG plot. It's the exact same stuff as before, with kind of the difference being I want to fill the bars by low being red and high being green. So North Carolina, the champion, by the end of the season, they're going to be in bright green. Transition time is based on game number, so that's what we're going to be kind of parsing along as the animate goes along. And then all of my other stuff there is just purely for aesthetics. Labels, I have a caption there that gives reference to the data and where it came from, which is always important. And then the themes are all just relative to how I want my x-axis and y-axis and plot and subtitle and plot title and caption to look. So we run that. And then we run our little animate function over that plot. And I have this end pause equals 12 seconds because I don't want the plot to just end and then recycle automatically. I want it to basically kind of hold for a second so that you can get an appreciation for what's there at the end of the season before it kind of re-ups or restarts.
All right, so GG Animate's rendering it now, and
here we go.
There you go.
So you can see Portland's in the mix. They're kind of tied with North Carolina there for points, and then North Carolina just takes over. And you can see by the end of the season, the last two teams standing are North Carolina and Chicago, who played in the championship, North Carolina winning. So that's one way to look at with the racing bar plots. We can also do this with a line plot, similar to what Owen did. So all the same information applies. I do that little pre-processing step where I create a game number column. And then the ggplot information is all the same, with the difference being I changed the geom line from geom call to geom line. And I'm having it colored by team. And then the transition time game number just makes sure that the historic points, cumulative points, is maintained across the entire season. So we run that, and we run the animate. And it's going to take a second to render.
Taking a little bit longer. Geom line is a little bit more intensive than geom call, I think, in creating the graphics. So it's creating a graphic for each game, and then adding transition information and whatnot. So gganimate generating the GIF.
And there we go. So now we see our teams slowly moving along, and then Portland, our North Carolina, takes over and absolutely destroys the league. And then the cool thing with this is, if you were trying to put together a report, you could knit this together, and similar to last week's screencast where we built a cool kind of online report, this will produce an HTML, and all of the interactive graphics, or the animated graphics, will actually stay. So so you could build a full report using last week's screencast and this week's screencast. You could build a full report on the 2019 NWSL season. You could have interactive graphics with players. You could have animated graphics with the team and how the season unfolded, and things like that. And so now you have a cool report that you could send around to colleagues or friends or whomever.
Yeah.
There you go. Right.
Awesome. That's a great example of how to use gganimate, Patrick. Thanks for putting that together. So I think that brings us to the end of this episode of TidyX. If you have any code that you'd like to have us go over and explain, you can reach out to us at tidy.explained@gmail.com. Otherwise, you can find me, Ellis Hughes, at Ellis_Hughes on Twitter.
And you can find me at OSP Patrick at Twitter as well.
All right. Thank you. And we look forward to hearing your comments. Please like, subscribe, and we'll talk to you all soon.
Thanks.